Hello friends, it's Arun Singh here and welcome you in my new playlist on design pattern introduction. What are design patterns, when to use them, how to use them? Let's see. What is design pattern? Design patterns represents the best practices used by experienced object-oriented software developers for general problems that software developers face during software development. That is, design patterns are commonly defined as time-tested solutions to recurring design problems. I have one problem in my software. So there is two ways that I can take. Either I can reinvent the wheel or I can go and check how other software developers has found out the solution of that problem. If it is a problem which everyone has, then definitely there would be a time-tested solution that already were in the market, and that is the design pattern. History. In 1994, four authors, Eric, Gama, Richard, Ruff, and John, published a book titled Design Patterns, which initiated the concept of design pattern in software development. That is the concept of 1994. These authors are collectively known as Gang of Four. Categorization. Actually, when we talk of design patterns, they are basically of three types. First, creational, second, structural, and third, behavioral. Let's talk about creational design patterns. Offer solutions for solving different problems that occur during object creation. When we talk of structural design patterns, they offer solution to instantiation problem by finding ways how the class can be composed in larger structure. These are mainly related to class composition. And third, behavior offers solution to problems that happens in the communication between separate parts of the code. I have one method, I have second method. How these two methods will communicate? Look in behavioral design pattern. Let me go one step down. How many creational patterns are there? There are lots of creational patterns. I will have a look only for the few which are majorly used and in the market. I will talk about abstract factory, which creates an instance of several families of classes. Builder separates object construction from its representation. Factory method creates an instance of several derived classes. Object pool avoid expensive acquisition and release of resources by recycling objects that are no longer in use. Prototype, a fully initialized instance to be copied or cloned. There are several requirements of creational design pattern. Whenever you will talk about object creation, you have to talk about creational design pattern. And last not the least, singleton design pattern, a class of which only a single instance can access. I will see in depth all these patterns in my future video tutorials. Let's talk about structural design patterns. Already a one input and you have requirement of another input or output. So what I do, transformed my input and output using an adapter design pattern. Match interfaces of different classes. Bridge separates an object interface from a simple implementation. Composite, a tree structure of simple and composite objects. Decorator, add responsibilities to object dynamically. Basically, in decorator design pattern, you have one object, then you will add some functionality to it, then you have another, then you will add some functionality to it, and add responsibilities to each stage of the object. Facet, single class that represents an entire subsystem. That is, a single class which will represent the entire subsystem. It's an important distinction. Flyweight, a fine-grained instance used for efficient sharing. Proxy, an object represents another object. Let's talk of behavioral design pattern. Chain of responsibility. Basically, ATM is a best example of chain of responsibility, where each component will do its work and move the other part of the work to the where the desired goal is for it. I have class. I have break that class into different classes. I will perform this functionality here, this functionality here, this functionality here. This example has taken from the basically mechanical engineering, where we have a chain for mechanical engineering for creation any objects. A way of passing a request between a chain of objects. Command encapsulates a command request as an object. Iterator. When you are working with collections, you have a lot of used iterator over there that is sequentially accessing the elements of a collection. Memento captures and restores an object internal state. It is important. Observer. Whenever you are surfing on any website like Amazon, Flipkart, basically you place some orders and that object is not there. So observer design pattern is somewhere implemented where it tracks that something has changed. When that object will come into the picture or into the basically that store, they will respond you back. That is the observer design pattern. A way of notifying changes to a number of classes. This object is finished, now it is back to the market. Let me notify you back. Strategy design pattern encapsulates an algorithm inside a class. And last, not the least, template method refers the exact steps of an algorithm to a subclass. Basically, we have a template. We create a template and then we replicate that template for each object creation. That is the behavioral design pattern. When we talk of design patterns, there is also a need of anti-design patterns. Why it is used? Let me talk about it. An anti-pattern is a literary form that describes a commonly occurring solution to a problem that generates decided negative consequences. Let me repeat this. That generates decidedly negative consequences. When I take any approach, I know that it has some pros and cons. Now, sometimes pros are not much beneficial to me, but cons are impacting me high, and that approach is already implemented. So what is the solution for that? The solution is to take the anti-design pattern. At this condition, we need to implement the anti-design patterns. Anti-pattern may be the result of a manager or developer not knowing any better, not having sufficient knowledge or experience in solving a particular type of problem, or having applied a perfectly good pattern in the wrong context. This is a developer problem or management problem. When you have the solution, but you have implemented it wrong. So now you have to go for the anti-pattern. What are the types of anti-patterns? Like software development anti-pattern, software architecture anti-patterns, and software project anti-patterns. Let's start practical.